This is A-level maths. It's paper 1, so it's all pure, and it's the 2023 paper. Find the coefficient of x to the 7 in this. Well, if you imagine this as just like writing out all of the brackets, to get x to the power of 7, the only way to do that is to multiply this number by this number by this, all the way to the end. So you're just taking the first term of each binomial. In other words, you're just doing 2x to the power of 7. If you put that into your calculator off, you just know it because it's not too difficult. It's 128 x to the power of 7, and the coefficient is 128. So it's this one here. Given that 2x cubed equals y, find dy by dx. It's just simple differentiation. You multiply the power by the coefficient and then reduce the power by 1. I've written out like this. And 3 minus 1 is just 2, obviously. So this is the answer. We've got this curve here, y equals ln x, and it's transformed parallel to the x-axis with a scale factor 2. It's been stretched out. So if you imagine it, inside of the brackets, it kind of does like the opposite of what you'd expect it to do. Right? So if it was 2x here, ln of 2x, you'd squish it in by a factor 2. But if it was ln half x, it would stretch out by a scale factor of 2. So this is ln x over 2. You should just know your graph transformations from GCSEs. Theta is a small angle. Find the approximation for cosine 2 theta. Just open up your formula booklet. You'll have this. Okay. Instead of theta, you've got 2 theta. So just replace theta with 2 theta. You'll get just this. I mean, you know how to simplify this. And this is your answer. Trapezium rule now. We've got y equals, we've got this graph here, okay? If you just open up your booklet, you've got this formula, right? And so h here is just where b and a, b will be this number here and a is this number here. So b take away a over n, where n is the number of strips, and we're told 5 strips. Careful, it does say 6 ordinates. There'll always be one more ordinate than the number of strips. Just remember n is the strips. So this is going to be 4 minus 1 over 5 for h, so that's 3/5. Okay, now y subscript 0 and y subscript n is just the first like pair of like values, and then the last pair, right? If you just imagine it, you're going at y1, y2, y3 all the way up to yn, the last strip, so that just must be the last like pair. It's the last y value, by the way, because it says y, and then y0 is obviously just the first one. So this is the first one plus the second one, plus the last one, sorry, multiplied by a half h, where h is this, so that's 3 over 10, and then 2 lots of everything else in between. So it's this plus this plus this plus this, right? Just put that into your calculator, you'll get 2.3315. Using your answer to pi, deduce an estimate for this. Now, I've just brought up the question here. If you notice, to get from here to here, all they've done is, if you just imagine this is y equals, say like f of x, what they've done is they've just replaced, actually no, that's not a good way to describe it. What they've done is they've just multiplied it by 4, okay? So if we got the area for this to be 2.3315, and this is 4 times that, within those same limits, then we can just say the area is just 4 times greater. So it's just 2.3315 multiplied by 4. So you get this. Show that the equation this has only one solution. So the way that you do this is, basically, what I did was I brought this to here and brought it to the power of x here, because you can do that in logs. So this becomes log base 10 of x squared. And then you've got this. The reason why I did that is because then I'll be able to group up these two, because when I subtract log base 10 of 4 on both sides, I've got a log of the same base subtract another log of that same base. So that means I can just divide the inputs and put them in the same log. So this is log base 10 of x squared over 4. And now because I've got log base 10 of both sides, I can just do 10 to the power of this and then 10 to the power of that, because I'm doing it to both sides. So you get x squared over 4 equals x plus 8. Just multiply by 4 on each side, and then just rearrange to get this, and then this factorizes into x minus 8, x plus 4. You have solutions x equals 8, x minus 4, but you can't have minus 4 because say like here, right, you're going to have log base 10 of minus 4, but you can't have a negative input for a log, so you just have to say that and then just discard that solution and show that say that x equals 8 is the only solution. N is a positive integer, sorry, and we just want to basically rationalize, okay? Oh no, we're not rationalizing, I don't think. Okay, yeah, we're just bringing them together. So multiply this by this, and then multiply this by this as well, and then multiply this by this, and then multiply this by this to get that. And then just expand and then simplify. I'm sure you know how to do that. You'll get this. Okay. Hence deduce that is a rational. This is a rational number for positive integers. Positive integer values of n. We got this as our result. Okay. Well, it's just rational because 42, 25n, and minus 9 are all integers, right? So you can just it's just rational. I mean, there's nothing there that would make that irrational. It's not like it's like there's no way to get 1 over, say, like 3 or something, or 2 over 3, or 2 over some multiples of 3 that would just give you a recurring decimal. And also we don't have any surds in there. Show that this equals this. This is just integration by parts. You do have a formula for this. This is the formula. You just open up your data booklet. What I did was I said that I just let u equal x here, and so dv by dx is just sine 4x. And the reason why I did that is because we know that we're going to be differentiating u when we get du by dx, and it's just simpler because x just simply differentiates to 1. And then dv by dx is sine 4x, so that means when you integrate it, it's going to be minus a quarter cosine 4x. If you think about it like this, sine integrates to minus cosine, and then this here, if you just integrate the inside and then bring it out and multiply it by here, by just by the coefficient, which was originally 1. Okay, and then you obviously just keep the input the same. Okay, and then just plug it into the formula. You've got u multiplied by v, so uv. Okay, so that's minus a quarter x. Okay, sorry. U multiplied by v. Okay, because this is our left hand side. So you do u multiplied by v, which is x multiplied by this. Now, when you plug in, because cosine 4x is where x is just going to be pi over 2, and so if you do 4 multiplied by pi over 2, that's just 2 pi, and then cosine of 2 pi is just 1, so this will just be minus a quarter x. Okay, and then that's just fine. That's fine. You can leave it like that. And then we've got the limit, so we're actually going to plug in the limit. So when from 0 to pi over 2. Okay, this is just minus pi over 2 over 4, so it's going to be minus pi over 8, and then it's just subtract when you plug in x equals 0. But when x equals 0, this just goes away to nothing. So your final answer is just minus pi over 8. The points P and Q have coordinates this and this respectively. Find the coordinates of the midpoints of P and Q. So you just add up, you just basically average the x coordinates and then average the y coordinates. So minus 6 plus 12 is going to be 6, and then 6 divided by 2. And then 15 plus 19 divided by 2. It gets you this and this. Find the equation of the perpendicular bisector of PQ. Now PQ have these 2 points, okay? And we've got center this. So that means when we find the line PQ, and then we find the negative gradient, so when we find the perpendicular line to it, we want it to pass through the center because it bisects the line, so it goes through the middle. Okay, so we'll find the gradient of this. Let's change in y over change in x. So 19 take away 15 divided by 12 take away negative 6. So that's 12 plus 6. You get 2 over 9 for that. We want minus 9 over 2 because it's the negative reciprocal because we've got a perpendicular gradient. Use y minus y1 equals multiplied by x minus x1. Okay, just use any point. Oh no, sorry, don't just use any point. Obviously use the center because it's a bisector, as I've just explained. And then just rearrange. You want it in this form. You know how to do that. You'll get this as your final answer. A circle passes through points P and Q. The center of the circle lies on the line with the equation this. Find the equation of the circle. We've got these 2 points here, okay, and we've got the perpendicular bisector being this, as we've just worked out. What we're going to do next is to find the center, right? It's going to be where this perpendicular bisector intersects this line here. Okay, and so whenever 2 things are intersecting, what's happening is that you're just solving them simultaneously to find the points of intersection, or in this case, the point of intersection, right? So either rearrange for x or y, in either one, it doesn't matter. I rearranged for y here, and then I plugged it into there, okay, to get this, and then I multiplied out by 2, I think. Yeah. So multiply out by 2 on both sides, and then just rearrange. You've got a calculator, so you can do this pretty easily. You'll get x equals 5 for the center, and then if you plug that into any one, you'll get y equals 8 for the y coordinate of the center. So the center is 5, 8. This tells us that the general equation of the circle is going to be like this, where a and b, or in this case 5 and 8, is the center, and yeah. And so if this is the center and p and q both lie on the circle, then we can just set up Pythagoras. So, if you imagine the circle like this, we've got a point here and we've got the center. We just need to go from that center to that point. So say if we pick this one, for example, from 5 to 12, it's you're going across 7, and then from 8 to 19, you're going across 11. So it's just going to be the square root of 7 squared plus 11 squared. So 49 plus 121 square rooted is oh, you don't even need square root because you want it r squared, so that's fine. Now the circle intersects the coordinate axes at n points. State the value of n. Well, what you can do is just plug in x equals 0, right, to find where it intersects the y-axis, right? So just do that and see if that solves. It does solve. You can go ahead and check if you want, but this definitely solves. Okay, and then just plug in y equals 0 to find where it intersects the x-axis. Don't know why I was thinking for so long on that, but anyways, yeah. So you have 2 solutions there, 2 solutions there. It's going to be y squared, and a polynomial of degree n has n solutions. So y to the power of 2 will have 2 solutions. Same with x to the power of 2, that'll have 2 solutions. So in total, it has 4 solutions. The curve with equation y equals sine x is shown here. The point A on the curve has coordinates a 0.5. It's this point here, okay, and find the value of it. Well, if it's 0.5 high, right? If we just draw this line, it's going to be the same as this point, and the same as this point. Now, it's easier if we just have a look at this point. Now, say this one here, we know this is going to be 30 degrees because we know that sine of 30 degrees is a half, because you should know your exact values, and because they're on the same y-axis, right? Not axis. They're on the same like this like y equals 0.5. It means that they're related in some way, and their relation is just going to be that you can just take away pi to get this solution here. So this is 30 degrees here, right? And then this one here is just 180, take away 30 degrees, right? And so, okay, so what I've done was, I've gone forwards to 150 degrees, and then I've gone backwards 360 degrees to get to A. Okay, the reason is because this point here would actually be related to this one, and then this one here would be related to this one. If you imagine how sine repeats, if you imagine you've just moved this full graph to the right, this entire part of the graph is the same as this next one here, and so if you map it on this one, you'll find that A is actually this point here. Okay, so x would just be 100. Would just be no, it wouldn't be 150 degrees. It'd be 360 minus it, because you're going back that way. Sorry, minus 360 plus it, so you get minus 210. Obviously, it's negative. State the value of sine 180 minus A. Well, we know A is just minus 210, so 180 minus 210 is just 390. That's fine. But the only thing is that you have to worry about is look at this range that we've got. We've got from minus 360 to 360. This is out of our range by 30 degrees, but it's fine because sine repeats every 360 degrees, or 2 pi, so you can just take away 2 pi 360 degrees from this to get 30 degrees. So yeah, and then sine of 30 degrees is just a half, because this entire thing is 30 degrees. Find the exact value of B, take away 180 degrees, and B is this point here. The way that I thought about this was graph transformation. Now, we know that to get say if I have this solution at 30 degrees and then I have another one 150, the way that we did that is we did 180 degrees, take away 30 degrees, right? And so whenever you go forwards 180 degrees, you're just getting the other solution within that, like, within this small, like, part of the graph, right? Similarly here, to get from here to here, you just add 180 degrees. Sorry, no, not from here to here. So this is 180 degrees, and then you'll go forward some amount, and then from what you can do is you can go from 360, and then you can go back that same amount to get the other value for b. But because we just said, you know, you can do 180, take away that, right, to get the other solution, and or 180 degrees, take away this many degrees across to get this solution. We can conclude that whenever we're adding 180, well, taking away 180 degrees, what we're doing is we're just finding the next solution in that period. But if you have a look at where b is right now, it's below the x-axis, right? So, and we have a negative y value. But the thing is, when we do b degrees minus 180 degrees, we won't have a negative solution. Because if you imagine this in terms of graph transformations, which is what I did, is I imagined moving this 180 degrees forwards. We know from here to here is 180 degrees, as I've just said. So from here and then forwards 180 degrees will actually get you above the x-axis. So it won't be minus 3 over 7. Instead, it'll be positive 3 over 7. Hopefully, I explained it well enough. I don't know, that seemed kind of a sloppy explanation. If anybody's confused about it in the comments, I'll, you know, try and explain it a bit better. I think I'm just trying to be a little bit quick because I don't want to spend too long on this paper. Find the exact value of cosine b. B is this, right? Okay, we know that sine b is just minus 3 over 7 because that's what it said in the question. So I just had to quickly pause to do something. Anyways, we know that sine b is this because the question told us. And if we have a look at the sine graph, which I've just copied from the other question, we know that it's a little bit further than 180 degrees, and that's obvious. Between 180 degrees and 360 degrees, anything that is like sine of it is just going to be negative, right? So if the angle lies between 180 degrees and 270 degrees, it's just going to be negative, right? What we can do next, right? I'm sure you've done many questions like this, so you know what I'm going to say, is we're going to square both sides to get this. Right, and we know that sine squared x plus cosine squared x equals 1, or b, or whatever, it doesn't matter. And so if we rearrange for sine squared, you'll get 1 minus cosine squared b equals m sine squared b. So we can replace that with that, right? So you have this, and then just rearrange for cosine squared b, you'll get this. Now, just be careful, because when you square root, you're going to have a positive and negative answer. But one thing to point out is, if you have a look at the cosine graph now, between 180 and 270 degrees, well, look, between 180 and 270 degrees, it's actually negative, right? So when we square root this, we're going to take the negative solution, okay? So, yeah, just take the negative solution. So it'll be minus root 40 over 7. Obviously, root 49 is just 7. Okay, this simplifies into 2 root 10, and that's fine. Yeah, so you can just say your answer is minus 2 root 10 over 7. The nth term of a sequence is un. It's defined by this. u1 is 400 and p is a constant term. Okay, so when n equals 0 here, we've got u1, right? Because it's 0 plus 1 is 1. So when n equals 0, u1 equals 400. So we've got u1 here, right? And we just know that equals 400. Okay, now u2 would just be when n equals 1. Okay, now n equals 1 would have p multiplied by u1. We know that u1 is 400, so that's 400p, and then it's plus 70, right? And we can kind of just carry this idea on. Is that fine? Is that all I needed to show? Okay, no, yeah, never mind. Yeah, that was it. I didn't even read the question, but yeah, that's fine. You'll get a mark for that. Show that p satisfies this equation, and we're given that u3 is 382. Now we're just going to use the exact same thing, and then do it again. Okay, this was the sequence, by the way. So u3, which is the next one, will equal p multiplied by the current one, which is this, plus 70. Now, p multiplied by the current one is this, plus 70, and we know that equals 382. Just expand and then rearrange, you'll get this. And then you can actually divide by 2 on both sides here, and that's fine, because that's that. Find the value of u4 and the value of u5, and we're given that it's a decreasing sequence. Okay, that'll be important for later. If you just solve this, put this into your calculator, you get p is this or p is this. Okay, and u3 equals 382, so we can just plug that into this to get u4, right? Okay, and we know that p is either this or this. Now, don't just assume that because it's a decreasing sequence, p must be this one here, which is negative, and so that must be the answer. Just like slow down a little bit and just just try it, right? You've got 2 hours for this exam, so just try stuff. Okay, plug in this. So you'll get this, okay, and then just plug in to get u4, and u4 is this. Okay, now find u5. u5, whatever it is, it's going to be greater than 0 because we've got a negative multiplied by a negative and then add 70, so it's just going to be a positive. But notice how when we've gone from u4 to u5, we've actually increased. So this series between u4 and u5 is increasing, right? But we said it was a decreasing series. So that means p equals minus 39 over 40 is definitely not the correct answer for p, right? And so we'll try 4 over 5 maybe. So u4 is, just plug in 4 over 5. You'll get this, and then for u5, just plug it in again. You'll get this, okay? And this makes sense, right? Because it's decreasing. It's gone down by like 5 point something or whatever. Okay. So all of this you don't need it. This is just waffle, right? The limit of un as n tends to infinity is L. Write down an equation for L, right? This was our sequence with p, plugged in. Okay. N tends to infinity, right? So infinity plus 1 is just infinity, right? And we're saying as it tends to infinity, it's just called L, right? So this here is L. U of infinity is just un. Sorry, u subscript infinity is just infinity, right? And we've said that's L. So this is L equals 4/5 L plus 70, and that's fine. Find the value of n. Just solve this. You know how to do that. Just take away 4/5 from both sides to get 1/5 equal 1/5 equals 70, so L equals 350. We've got this question here. Okay, so let me can't actually remember because I did this paper quite a while ago and I've just not recorded it, so I've kind of just forgotten almost everything on it, which is which is the reason why some of my explanations are maybe not as good as they as you'd expect them to be, maybe. Anyways, hopefully doing a good job, right? We've got a ceiling, we've got a floor, right, and it's got a height c between the floor and the ceiling. Sorry, between this like thing here and the ceiling, and then the floor is f meters above the ground, and it's like a ride, and it moves over the course of 10 pi seconds. At time t seconds after the ride begins, the distance above the floor is modeled by this, and then at time t seconds after the ride begins, the distance c meters is modeled by this. The ride is shown in the diagram below, so it looks like this. Show the initial distance between the floor and the ceiling is 8 meters. Okay, this is simple. This is just c. Take away f here to get this. Right, we know what c and f are. We just plug them in. You'll get this, and then the initial distance would just be when time equals 0. So plug in 0. The sine of 0 is just 0, and then cosine of 0 is just 1. So 7 plus 1, which is 8. Show that the distance d meters between the floor and the ceiling at the time t is given by this. Okay. What did I do? Let me actually see how I've gotten to that. Okay. So the distance between these 2 points here, right? We've just said that's called d, and that's obviously just this. It's just c take away f without t's plugged in, without t being 0 plugged in. So that's where that comes from. Okay. Now you should have done this when preparing for this exam. This is auxiliary angle, and what we're saying is that if we've got two trig functions, sine and cos, right, of some input, we can represent them as just one trig function, either sine or cos, where the input is just it's this exact same thing here, but the only thing that's changed is the phase, and the phase here is represented by plus alpha, right? So we can say that a sine t plus b cosine t is identical to r cosine of t plus alpha, right? Hopefully you would have seen that. And I'm just you might just know how to actually set this up and do it really quickly. I'm just going to go through it slowly. We've got this in the book, right? We've got plus. Okay, so we'll use plus. Just one thing to point out here. If it's plus here, then you're going to use the minus here. But if it's minus here, you're going to use the plus there, right? I apologize if you can hear my brother in the background. He's just a baby. Anyways, we've got our cosine, okay, and it's plus t plus alpha. So we're going to be using cosine A, cosine B, minus sine A, sine B, right? Just using that, you know how to use that. But it's r multiplied by all of it. Distribute the r to get this, and then we can equate coefficients because these two are identical. So if we have a look at the sine t's, the coefficients of sine t, well, we've got a on this side. That equals minus r sine alpha, right? And then for b, we've got, if we just look at the cosine t's, we've got b equals r cosine alpha, okay? And then a over b is just going to be minus tan alpha because we're just doing sine over cos, but it's a minus sine over cos, and then the r's cancel. This just becomes minus tan alpha, right? And then what I did was I brought this to the I brought this to one side and then brought this to the other side. Then I did inverse tan of both sides to just get the angle alpha, and I got it as this. So we can say that the phase is represented by a over b, where a is the coefficient of sine t and b is the coefficient of cosine t. Now, to relate that to this, right, a is going to be minus 4 and b is just going to be 1, right? So just do that. So inverse tan of 4 is apparently what alpha is, that's 75.96. And then r, what r is going to be is just going to be, it's just the square root of a squared plus b squared. What you can do is you can just draw yourself a triangle. I don't know if I did it here. No, apparently I didn't. If you draw yourself a triangle, right, and the opposite side is a and then the adjacent side is b, the hypotenuse, so the other side, is going to be the square root of a squared plus b squared, right? Hopefully that makes sense. And yeah, so you just get this. You just plug r back in because it's I cosine t plus alpha. Hence, find the minimum distance between the ceiling and the floor. Give your answer to the nearest centimeter. Now, for this to be a minimum, you want this to be the least value that it can be. Now, you don't actually have to find what value of t gives you a minimum. All you have to know is, well, what's the lowest that this can go? Well, the range of cosine is between -1 and 1. So the lowest this can be is -1. So let's just pick it to be -1. Okay, and then so it just replaces this entire thing with -1. So you get 7 minus root 17, which is 288 centimeters. We've got a function f. It's defined by this, and it's inverse cosine, right? State the value of a. Well, this is when y equals 0 or when f of x equals 0. So inverse cosine of x just equals 0. If you do cosine of both sides, cosine of 0 is just 1, so a equals 1. Okay, on the diagram below, sketch the curve with y equals cosine x between this, and then sketch the line with the equation y equals x. Now, y equals cosine x, it's kind of hard to draw it on PowerPoint, but, you know, it starts from 1, and it goes down, and it hits pi over 2. Right, or 90 degrees. So it starts off at 1 and it goes down like this. So yeah, when you should know how your trig graphs look. I mean, you did this in GCSE, and then yeah, that's fine. And then sketch the line. Yeah, and then sketch the line y equals x. Now, what I did was I actually just made myself some like guidelines because I know that it has to pass through pi over 2, right? Because if you imagine, well, the x and y coordinates are going to be the exact same. So, these are the exact same. So it must pass through this point. And so it passes through this point as well. So it's just a straight line going from here to here. This is not perfectly through the origin, but that's fine. You know what I mean. Explain why the solution to the equation x minus cosine x is also a solution to the equation cosine x equals arc cosine x or inverse cosine x. Well, what you can say is, like, whenever you've got something like this, right, what you're saying is, when does the graph of y equals cosine x intersect the graph of y equals inverse cosine x, right? And when does the graph of cosine x, when you bring cosine x to the side like this, when does the graph of cosine x intersect the graph of y equals x, right? And we've just graphed all of those three functions on here, right? And so, you know, if they all intersect, right, they must have solutions, right? And because they all intersect at the same point, they also must have a common solution, right? It'll only be one, but it is a common solution nonetheless. Let me think. Would it be? Yeah, yeah. There's only one place where all these graphs intersect at the same time, and you can see that just by this. Use the Newton-Raphson method with x subscript 0 equals 0 to find the approximate solution to x subscript 3 to the equation this. This is the method you're given it in the equation book, right? And if you just say f of x equals this, okay, as you usually do in questions like this, because f of x equals 0, we want to differentiate it here, right? So we'll do that. This differentiates to 1. Minus cosine x differentiates into sine x, so it's going to be 1 plus sine x, right? And then literally just plug in the values. You know how to do this. X1 equals x0, was it's just 0, minus f of 0 over f prime of 0, right? That's fine. That's literally it. Cosine 0 is just pi, and then sine thingy is sorry. What am I even doing? What am I looking at? Okay, yeah. Sine of 0 is just 0, right? Cosine of, wait a minute, what did I say? Cosine of 0 should be 1, right? Sorry, that's 0 minus 1. To be honest, I just paused to check as to why I've done this. I have no idea, right? It doesn't actually matter because of the way the graph repeats, but yeah, right. You could just say that cosine, you could just be normal and say that cosine theta equals cosine 0 equals 1. So you have minus 1 over, and then sine 0 just equals 0. So you have minus 1 over 1, but subtract it, so it becomes a positive 1. So x1 becomes just positive 1 instead of this. It doesn't actually matter because your calculator has an answer button, so just plug it in and then press that a few times. Yeah, to find the next solution, x3. And then you'll get this for your answer. Given that y equals 2 to the power of x, write down dy by dx. Now, I actually went through this the longer way, right? Just to kind of show you. But the way that, if you don't know how to do this type of question, actually, no, I'll just show you, okay? So say you have 2 to the power of x. That's the same thing as saying e to the power of ln2 multiplied by x, because this and this cancel, and so you'll just get 2 to the power of x still, right? Hopefully that makes sense. This is because it's e to the ln2 all to the power of x, and then the powers just multiply. But then either way, you get 2 to the power of x, right? That's fine. Okay, I'm going to say y equals this, okay? And then I'm just going to differentiate this. And this just differentiates into 2 to the power of x multiplied by ln2. You should know how to differentiate something like this, hopefully. To integrate this, right, this is just whatever this number is to the power of x divided by ln of whatever that number is, right? Where it's just x. It's not like 3x plus 4 or something random like that. Alright, so this then would be 2 to the power of x over ln2. And then because we're integrating and we've not got any limits, there's a constant of integration, which we'll just call c. I don't know if you drop... I can't remember if it said in the mark scheme whether you drop marks if you didn't put that. Not too sure, just try and remember it, hopefully. We've got this graph here, y equals 2 to the power of x, as we've just looked at. And then we've got, we're told that it's bound by the line x equals minus 4 and then x equals 0. The area of the largest triangle is root 2 over 4, and we need to show that. Right. Well, if they're rectangles, right, they've all got equal width, and we've got a space between them of 4, and we need to show, we need to, like, there's 8 rectangles here, by the way, as it says, obviously, and so we're going to split that 4 into those 8 rectangles to find what the width is of just one, right? So we've got 4 divided by 8, which is just a half, and that's the width, right, of any one rectangle. And so yeah, if we're looking at this largest rectangle here, right, and we're saying that the distance between them is a half, right, this x value is going to be minus a half, right, because we're going backwards a half. right? So the x value is going to be 2 to the power of minus a half. Careful, don't put in 2 to the power of 0 because you'll be all the way up here. We want 2 to the power of minus a half to get up to here, right? And that gets us the y value because, you know, we can relate those two. And you get root 2 over 2 for the y value. So it's got a height of root 2 over 2, a y value of root 2 over 2, and then an x value or a width of a half. Multiply that together to get root 2 over 4. The areas of these rectangles form a geometric sequence with common ratio root 2 over 2. And we want to find the exact area of all of these. You could do it the slow way if you wanted. It doesn't matter, you'll get the same answer anyway, so you won't drop marks for it. But say if you just use the formula, right, which you're given is this, it's just a little bit quicker. Be careful here, the common ratio is root 2 over 2. This value here is less than 1, right? So if you imagine this sequence, as we're going onwards, the numbers are decreasing. So the areas, as we're going forwards, are decreasing, which tells us that the first term isn't actually the value of the area of this. Sorry, the value of the area of this rectangle here. It's actually this one, because we're decreasing. So a equals root 2 over 4. And then n is just 8, because there's 8 rectangles. And the common ratio r is just root 2 over 2, obviously. Put that into your calculator. Oh no, never mind. Actually, you know what, you could actually just put this into your calculator and then it'd actually just simplify it completely for you because there are no variables here. If you want to do this normally, this is 2 to the power of a half. A half multiplied by 8 is just 4. And then the 2 to the power of 8 here, obviously. And the 2 to the power of 4 divided by 2 to the power of 8, you subtract the powers and because they've got the same basis. So this is just 2 to the power of 4. So this is one takeaway, 2 to the power of 4. Is that what I've done straight away next? Oh no, okay, what I've done is I've brought these two together. And then I've just said that 1 over 2 to the power of 4 is just 1 over 16, obviously, because 2 to the power of 4 is 16. And then 1 subtract 1 over 16 is 15 over 16. And we've got 15 over 16 multiplied by root 2 over 4, so that becomes 15 root 2 over 64 over the denominator. Whenever you've got a complex fraction like this, what you do is you can just multiply this denominator out up here, or you can just multiply this one down here. Okay, I think I multiplied it up for some reason, and then I brought it back down here. Oh no, for some reason I didn't do that. Right, it's because it's just simpler when you're rationalizing. So yeah, just rationalize this because you want the denominator out. You want the said out of the denominator. Gosh, I can't speak. So yeah, you just multiply by the conjugate, top and bottom. This becomes 4 subtract 2. So this is just 2. You'll get this on the top. And then what did I do? What I would do here is I would just have them over the same denominator and then bring the denominator down to get this. This simplifies into this, apparently. And you can then you can take out 15 over 32 from it to get 1 plus root 2, which means k is 15 over 32. More accurate approximations for A can be found by increasing the number of n of rectangles used. Find the exact value of the limit of the approximations of A as n approaches infinity. So what I was saying is just use infinite rectangles. If you just think about what integration actually is, you'll just realize, well, that's just integration using infinite rectangles to sum an area. So actually just integrating this. Now you already know that this integrates to 2 to the power of x over ln2 because we've already had a look at it, and it's between it's from minus 4 to 0, right? So just do that. We've got a constant term 1 over ln2, so I just took that out, and then this becomes much easier to do. Just plug in x equals 0, and then subtract that from when you plug in x equals minus 4. You'll get this. 2 to the 0 is just 1, and then 2 to the minus 14 is 1 over 16. So it's going to be 1 takeaway 14 over 16. Sorry, no, 2 takeaway 1 over 16. I don't know why I said 14 over 16. And then you'll just get this. You'll get 15 over 16 multiplied by 1 over ln2, so you get this. We've got this equation here, right? And we're told it looks like this, and it's got a stationary point P. If it's got a stationary point, that means the first differential is just going to be equal to 0. So just differentiate this. It's implicit differentiation, but it's fine. It's not too difficult from just normal differentiation. So just differentiate this, differentiate this, differentiate this. You'll have to use some product rule. It's fine though. The way that you do this is you differentiate we're differentiating with respect to x first of all, right? That's why it's called dy by dx. The dx tells us that we're differentiating with respect to x, right? So whenever we're differentiating with respect to x, that means, and we're working on x's, that's fine, we can do that. So this just becomes 2x. Now here, we're going to be differentiating y, but we actually want to be doing it with respect to x. So you can differentiate this, but you just always have to put down a dy by dx. Similarly here, when we're going to be doing this on here, we'll always put down a dy by dx if we've differentiated something other than x, even though we've said that we are differentiating x. Okay, hopefully that makes sense. So yeah, this becomes 3 times 2 is 6, 6y to the power of 2 dy by dx, is because we always put it. And then here is product rule. So we'll differentiate it with just looking at the x's. So basically differentiate one, and then leave the other the same, and then differentiate the other, and then leave the other one the same, and then you just want to add them together. So if we differentiate the x here, we'll get x differentiates to just 1, so this becomes minus 4y. Then we're going to add that onto just differentiating y, so this becomes a minus 4x, because y just differentiates to 0. Sorry, to 1, not 0. And then obviously add the dy by dx, because we've differentiated y. You'll get this. Factor out dy by dx, and then bring the 2x to the side, bring the minus 4y to the other side to get this, and then divide through like this. That's fine. That equals 0 because it's a stationary point. And then you can just multiply this both sides. This goes away to 0. So you get 4y minus 2x equals 0. So you get x equals 2y. And then we know that x equals 2y, so just plug that back into there. And that's fine. Just expand and be careful. You'll get this, and then factorize to get this. That's fine. The reason why we did this into this is because, well, we've got the x coordinate. It's just some number here, 2y, right? We can just plug it back into the equation to find out what y equals, because this is just the equation y equals this. Okay, hopefully that makes sense. And yeah, that's that. Hence, find the coordinates of p. Well, we've just solved this, right? Either y equals 0, okay, or y equals 2. Now, just by looking at it, we can see that this y coordinate here isn't 0, right? This one here is 0. So there's a stationary point at 0 as well, apparently. Unless it's like some other kind of point, it doesn't matter. We don't need to worry about it. But just by inspection, we can say y doesn't equal 0, so y must equal 2. And then we know that x equals 2y, as we found last time, so x equals 4. Given this, right, find the values of a and b. So this is just partial fractions. I factorized out a minus 1 from this denominator to get this. And this is a difference of 2 squares, so this is 3x minus 4, 3x plus 4. You'll get this. And then I just distributed the minus to one of them. I think I just did this one. So this becomes a 4 minus 3x. Okay, and that equals, it's actually identical to this, right? Because when you simplify this on the side, you'll get this exactly. I just didn't write down the identical symbol, but you know, I've said it, so you should know what I mean. Multiply out by the denominators. So when you multiply out by this one here, this b just becomes by itself, but you have to remember to multiply a multiplied by 4. Multiply a by this. And then when you multiply by the other one, you know, this here will cancel this, and then when you multiply by this one here, it'll cancel this one, and then that means that this one here is also going to be multiplied by it. Just do it step by step. You'll eventually get this. I'm sure you know how to multiply denominators because you're in year 13. Here, right, we want to pick a value for x such that we make either a or b 0, so then we can just look at one of them, right? So if we say that x equals 4 over 3, right, that means b will just go to 0, because the way that you do this, right, is you just take this bracket here and you set that equal to 0 and find what value of x makes it 0. You'll get 4 over 3, because 4 will equal 3x, and then x will equal 4 over 3. So this entire thing goes with 0. And then when you plug in 4 over 3, x equals 4 into 3 into this one here, you'll just get 4 plus 4, which is 8a equals 1. So a equals 1 over 8. And then when x equals minus 4 over 3, just by setting this bracket here equal to 0 and then solving for x, the a goes away to 0, and then we can find out what b is. B is also 8b, so b equals 1 over 8. Okay, and that's fine. That's what I wanted us to do. Now, we've got this container here, and we've got these dimensions, and we're saying that water is being poured into it at a rate of 0.16 cubic meters per minute, right? So we're saying that dV by dt is 0.16, but it's leaking out of the container by 0.36 d squared per minute, okay, where d is just the depth of the water, right? So it's actually this, but subtract the amount that's leaking out, okay? Now, at time t minutes, the volume of water is just v. So if you imagine it, the volume of water is just going to be this multiplied by this, multiplied by whatever the depth is, d. Not 0.5, it's d, because the water hasn't like fully filled this container. So 1.25 multiplied by 1.6 multiplied by d will just give you 2d. So the volume equals 2d at time t equals 2, right? And so we can rearrange for d to get v over 2, because now we can express this first differential just in terms of v's, which is what we wanted. Plug this into there and then just square, and then just put it into your calculator if you really want to. You should realistically be doing that just by yourself. I mean, 36 divided by 4 is just 9. Anyways, hence find t in terms of v. We know this here, right? Okay, never mind. Yeah, we know this here. What I did was I actually took the reciprocal of it, because if we have dt on the top like this, you could do it the other way. You'll just have to find the reciprocal like later on, and then you multiply by dv on both sides like this. What you can do is you can integrate this one side here, right, and then you can also integrate this other, because whatever you do to one side you'll do to the other. If you integrate dt, you'll just get t plus some constant, but you know, you don't actually have to include this constant here, just based off the context, right? And then we've got this here on the side. You can factor out the constant 100. Now, what's actually crazy is, in part A, they asked you to split this up into partial fractions, right? Because I did this paper, like, I didn't do it all at once and then record this video. I just split it up over like the longest time ever, because I just had other stuff to be doing. That's why I haven't posted in a while, right? So I actually just did all of this again, unknowing of the fact that I'd already done it in the part literally just before. So I'm just gonna skip through this, right, because I've already explained it. Okay, and then I'm gonna plug in a and b as 1 over 8. Okay, to get this. Okay, that's fine, and then just put it back into there to get this. You can just integrate this and then integrate this. What I did first was I actually took out 1 over 8, because it's similar between these two. You can factor out 1 over 8 out of this, and then because it's a constant, you can bring it out of the integral. So this becomes 100 over 8 multiplied by this integral. Now, this here, you should know this is it's like a standard integral that you learn. What you can think of it is it's just the reciprocal of, say if you had like 1 over x, and then you integrate it, you'll just get ln of x, or the absolute value of x. But if you had ln of something like this, you just take the reciprocal of whatever the coefficient of whatever you're integrating with respect to, right? And then you have that as be the coefficient of ln of whatever this entire thing is here, right? So this would just become minus a third, because the reciprocal of 3, the reciprocal of minus 3 is just minus a third, and then it's minus a third ln of all of this, right? And then this here will become 1/3 ln of all this, right? It's positive. Okay, I've put in these absolute value bars because it is the absolute value. Okay, plus some constant c, right? That's fine. I took out a third from these because they both share a third, so this becomes 100 over 24. And to deal with this c, we know that when time t equals 0, right, you've not filled up the container at all, so the volume should equal 0, right? So if you just plug in 0 into here, you'll have 4 minus 0, so you just have ln 4, and then you'll just have 4 here as well, right? So you have minus ln 4 plus ln 4. These two cancel, right, to get 0. So 0 multiplied by this, so you have 0 equals 0 plus c, which tells us that c just equals 0. So, you know, you can just get rid of the constant of integration. So you've done that now. You've found t in terms of b for 5 marks. And now for 2 marks, the last 2 marks of the paper, determine how long it takes to fill the container with water. Well, the volume is 1.25 multiplied by 1.6 multiplied by 0.5, which is 1, I think. Yep. Okay, and then just plug in v equals 1 into this. So this is going to be 4 take away 3, which is ln1, and then 3 plus 4, which is 7. Ln of 1 is basically just saying e to the power of what equals 1. Well, e to the power of anything equals e to the power of 0 equals 1, sorry. Right, so this entire thing just becomes 0. Right, so you have minus 0 plus ln7, so you've just got ln7. Just put that into your calculator, you'll get 8.1 minutes, and then to the nearest minute it's just 8 minutes. That's the entire paper. Thank you for watching.